Hello everyone, and welcome to a free video about Lightroom's tone mapping. Looking back at the classic books, The Negative and The Print, I think it was Ansel Adams who first illustrated the relationship between the exposure values that you find in the real world and the tones that you end up with on your print. And Ansel even created an illustration something like this, with 10 patches of gray that represented what he called exposure zones, numbering them 0 through 9. 0 would be pure black on a print, and he described zone 9 as a glaring white surface without texture or detail. He used a photograph of Long's Peak in that illustration, which I obviously can't reproduce here, so I've used one of my own. Same mountain, only shot from the east rather than from the northwest. Then for his middle tones, Adams cooked up a set of wonderfully uniform steps of gray, correlating his exposure zones to EVs, or exposure values, which are just measures of light that are related to the f-stops on your camera. So Adams' zone system essentially describes a sort of idealized film negative with a dynamic range of 9 stops. I use the word idealized because if you look at the tones in the Adams book, they look suspiciously uniform, with these nice even steps from zone to zone. Anyway, whether his tone mapping from exposure values to gray values was accurate or not is not the point. The point is simply that's what he was describing. Tone mapping from light values in the real world to gray values or lightness values in a print. It was when Lightroom 4 came along with the new 2012 process that I started trying to make my own correlations to understand the highlight compression I was seeing in Lightroom's tone mapping, which all of a sudden appeared to be much more powerful than what we had seen in any previous version. Take this photo of the hawk over Big Sur. This shot is clearly overexposed, with all these tones stacked up way over here on the right side of the histogram. But still, there's very little clipping, at least according to Lightroom's clipping indicator for the highlights. And pulling exposure down, it turns out there is quite a bit of tone in there, and some blue sky too, which is nice. Dragging the exposure down to about -2 stops or so reveals quite a bit of tonal variation all through the sky, where in the base exposure, all of this appears very flat and washed out. So we're going to take a look at this a couple of different ways, starting with the histogram. With exposure set back to 0, I'll grab my white balance tool so that you can see the numbers. When I roll the mouse around out here, what do you see? A lot of really high numbers that are all very close together, right? 96, 97, 98. All these very bright tones are all stacked up, and those tones are represented on your histogram way over here, all very close to the edge on the right side, which would be 100%, right? Okay, then watch this clump of tones up here in the very brightest part of the histogram as I drag exposure down. Dragging exposure down to -1.5 or -2 stops, and you can see very clearly how this expands the tones out. All these highlight tones that were compressed against the right-hand edge are getting spread out with the reduction in exposure. Once I'm down here at -2 stops, they're now taking up a full third of the histogram. That's what I mean when I use the words tonal expansion. Tonal expansion literally means spreading out the tones, which gives them more differentiation, right? And more tonal differentiation really just means more contrast in those tones. So the basic question here is, if my highlight tones are compressed like this by default, then where is that compression coming from? And the answer is that Lightroom compresses the luminance values from the scene in certain ways to give you the most pleasing look that it can in the default tone mapping. To see how that works, you sort of have to take apart the default tone mapping. And here's how you do that. First, you have to look at some numbers. Let's say, for example, that this highlight on your motorcycle has an exposure value of 12. Exposure values are just one way to measure luminance, and you find them on light meters because they have this very nice relationship to f-stops. And just like f-stops, each exposure value represents exactly half or double the amount of light as you go up and down the scale. Anyway, it doesn't matter how bright the highlight is. If you want to put it right at pure white, you choose some combination of f-stop and shutter speed to put it right at the very edge of your camera's ability to hold detail, pushing it up just high enough in exposure to the point where it clips to pure white. In an ideal 14-bit system, that amount of light will be recorded as a value of 16,384, because that's the largest number that can be stored in a 14-bit system. Then, if some other part of the scene measured an EV of 11, that amount of luminance would be exactly half the amount of the first one we measured. One full stop less light, right? So in the same scene, at the same exposure, an EV of 11 would get recorded as a value of 8,192. And then some other thing that was half the luminance once again, that would be recorded as 4,096, and so on. This is why we say that digital sensors are linear. Saying that sensors are linear is just another way of saying the values they record are directly proportional to the amount of light that was measured at any given pixel. Double the intensity, and the number is doubled. Cut the intensity in half, and the number will be half as large. So, pretty simple. Across the top here, I've just thrown out some possible exposure values, 1 through 12. If your camera is a 14-bit model, the numbers that we've been talking about might look something like this. And stop by stop, each stop of light is recorded as half the value of the previous one, down to somewhere in here, where, depending upon the dynamic range of your camera, you get to something that is the darkest thing your camera can pull out of the shadows, which really just means the darkest detail that it can truly differentiate from sensor noise. And down in here, you can see that you're also seriously running out of bits too, right? And so you have these numbers that have a very regular progression. If you were to plot these numbers on a graph, that would look something like this. Starting off very flat over here, where they all appear to be near zero, on this graph anyway, and then getting much bigger as they move up the scale, doubling in height with each step. But what this graph does not tell you is how your eyes respond to different intensities in the real world. Not at all. Down on this end, where the values all seem to be very close to zero, our eyes see quite a bit of differentiation down here in the shadows. But on a linear scale, the numbers make these tones look like they are very close together, as if they were all almost the same. Then over here, something else happens. In the very brightest areas of a scene, our eyes compress these large differences, making the very bright values appear much closer together than what this chart can show. And it doesn't stop here, where the bars literally go off the top of the chart. The possible range of values that we can see in the real world starts somewhere down below an EV of -3 or -4 for something that is lit by very dim moonlight, say, and can go up past 17 or 18 for very bright scenes. The range of luminance values out there in the real world is huge. It's way bigger than what your camera can possibly capture. So in that sense, what you're doing when you adjust your exposure is you're selecting a range of these values that you want to work with. And this is really what photography is all about. Then, if you're shooting RAW, Lightroom maps those luminance values that it finds in the file to some set of tones that range from pure black to pure white in the computer. This tone mapping from one world to another is called gamma compression and sometimes gamma encoding. This encoding compresses the brighter values using an exponential function so that you have more bits to play with in the shadows and so that your photograph is easier to work with by making the changes in tone more perceptually uniform, which is just a fancy way of saying making the progressions in tone behave more like the way your eyes work. To see what that looks like, if we take this set of linear 14-bit values that were captured by a camera and encode them into a working space that has a gamma of 2.2, the numbers that you end up with look like this. Then if you take that bunch of numbers and normalize them to scale up to 100 so that this top value here goes to pure white in Lightroom, then you get this set of numbers, which you can plot like this. Once you have that, plotting black to white from 0 to 100, you see this nice smooth progression of tones that's starting to look a lot like the bottom half of a classic H&D curve from the old film days. And this is what the actual tone mapping looked like for early digital cameras, with all the highlight tones just marching up the wall on this end and clipping into pure white in a pretty harsh way. Using a very simple function like this for the gamma encoding did give us a very smooth progression down here in the bottom half of the curve. But to make a digital capture look more like film, you've also got to roll off these highlights in a more gentle way to get that nice, smooth, film-like roll-off into pure white. Now, I don't really know what the math is to do that, and I don't really want to know. But if you want to understand how Lightroom compresses these highlight tones to give you that smooth roll-off into white, all you have to do is build a little setup or find some scene that you can photograph in RAW where you can make some fairly precise meter readings and then mark them off so that you can measure what Lightroom does with them as it encodes them into its working space. And that's what this is. This is nothing more than a long white card in a studio where I set up a light to fall off from one end to the other, and then I measured along this line with a spot meter to mark off where the exposure values were falling. The exact exposure that I used doesn't really matter. All that matters is that you have something you can measure that clips to pure white so that you know where that is, and then measuring with a spot meter, marking where each whole exposure value falls. Then photograph it. Once you have the raw file in Lightroom, you can just go down the same line and this time measure the gray values that Lightroom produces at each EV. So over here where EV12 was, I'm right on the edge of clipping. In fact, the green and blue channels in this file are clipped along this edge in this particular exposure. Lightroom just doesn't show you that because of the way the highlight recovery works, which is a completely different rat hole from the one that we happen to be in right now. So I'm going to use my highest value here, which is 99.8%, right along this edge. Then a full stop down from there at EV11, Lightroom is giving me a gray value of 98 or so. EV10 comes in at roughly 92%. EV9 is at about 80%, and so on, which over on the spreadsheet gives me this row of numbers right here, all the way down to an EV of 1, which in this exposure measures about 2% in Lightroom. Once we have that, the numbers start to tell Lightroom's story. I'll just select those numbers and make another bar chart out of them, like this. Now, with these numbers, you finally start to see a curve that really is starting to look like one of those H&D curves from the film world. Take a look at how each stop of exposure through the midtones creates all this nice contrast and tonal separation From EV7 to EV9, we're getting almost perfect 20% steps in tone. Then up here in the highlights, the Lightroom process compresses those tones so that they don't clip in such a harsh way, the way they did over here in the simple Gamma 2.2 encoding. Each stop of exposure through the middle here gives you 20% steps in tone. But then in the highlights, look at how those increases taper off, giving you this nice roll-off into pure white. At EV10, we only go up 12%. Then another full stop of increase from 10 to 11 is only going up 6% from 92 to 98. Another full stop from 11 to 12 still doesn't break 100 at 99.8%. Before this, I never thought a bar chart could be such a beautiful thing. So that's one way to look at the tones that are created from your raw file. Another way to illustrate that would be to look at the actual tones along with the bar chart. In this file, you can really see those large steps in tone across the brighter midtones, all through here. And the extreme tonal compression that's going on in the highlights also takes on a very visual reality when you look at it like this. You might think that the distribution of tones created by equal f-stops of exposure would be more uniform once they're encoded into Lightroom space, but they're not. This is the tone mapping that's applied to every raw file you shoot, and it's basically designed with one goal in mind: to make your pictures look good. And truth be told, the grayscales created from Ansel Adams' film curves probably looked a lot more like this than the perfectly uniform steps he first showed us back in 1948. But in retrospect, I guess we could cut him a little slack on that one. The original question that led us down that little rabbit hole was, how is it that Lightroom can pull all those tones out of the highlights as you bring exposure down? And I think by now you can probably see that the answer lies in the highlight compression. All you're doing when you pull the exposure control down is you're shifting all your exposure values on this scale to the left. Moving these top two values down into here spreads them out in a pretty significant way, because now they're falling on a completely different part of the curve. And that spreading out means greater contrast. You can see exactly the same thing happening, only in reverse, over here on the photo of the bellboy in Beijing. In this case, I'm pretty badly underexposed. Looking at the histogram, you see that all the important tones in the image are way down here in the bottom half of the scale, and the picture looks dark and flat. In this case, the spreading of tones that we get by moving exposure up is exactly what the doctor ordered, going up about 2 stops, and all these tones that were down in here are now moving into the middle of the tonal scale, where they have much greater separation. Looking at the graph again, the bulk of the values in the original exposure were being mapped into tones down along this part of the curve, where they were, well, dark and flat, pretty close together in tonality. Pushing the whole range up 2 stops moves those tones toward the middle, which puts them onto a much steeper part of the curve, where they have more contrast. Remember back at the beginning, we said that it doesn't matter what the original exposure values are. You control where they land relative to your camera's dynamic range with your exposure in the camera. Once you've made your exposure, Lightroom's exposure control then allows you to sort of move the underlying range of values up and down within the encoded space, which might look like this. Of course, you can't create detail out of exposure values that are clipped in the original, and shooting directly into the sun is a good example of that. If I take my white balance tool over here and look at the values right around the disk of the sun, you see the same thing that we had in the clouds over Big Sur. A lot of mid-90s, but nothing really clipping until you get right into the sun. This small circle of pixels is completely clipped, 100% in all 3 channels, which makes sense. But bringing exposure down, like this, eventually you do get down in here where those completely clipped values start to get some tone. At about -2.5 stops, I'm very close to that value of 92 that we had at EV10. Remember? Then at -3.5 stops, it's starting to move down even faster, at around 80% or so. And finally, at 4.5 stops, we're into those 20% jumps again, at about 60%. So pushing exposure up and down does move what is there back and forth relative to the encoded space. But if it's clipped from either end, then the tone that you can bring into play will be just flat clipped tone with no detail. So you can see where bringing that clipped highlight tone down 4 or 5 stops puts it right in the middle of the curve here, where we have the most contrast. I admit that shooting directly into the sun is an extreme example, but it does show you how moving exposure up and down gives you this kind of unexpected control over the tonal relationships that are created from the original captured values. Sure, to get here on the Bellboy, I do end up pushing some of the brightest tones over the edge into clipping. But if I turn on the highlight clipping indicator, you see that it's really only some of these very small highlights up along in here. If some of that goes to pure white in this correction, no big deal. With the 2012 process version, it's the extreme compression of the highlights that gives us a much more natural roll-off into pure white. In all these examples, it doesn't matter if you're pulling exposures down off of the edge, correcting overexposure, or pushing them right up to the edge, like we did in this photo. The compression of exposure values in the highlights means your digital photos will now have a much more film-like look. And so that's it. If you'd like to learn how to put all these ideas into practice to help you make your pictures look better in Lightroom, then check out my image correction masterclass on Melita.com. And so I'll see you there.